Hello everyone. Today we will study chapter 1 section 3, new functions from old function. If we know the old function graph of y equals x squared, which gives a parabola in the graph, now how can we draw the graph of those new functions, like the first one, y equals x minus 2 in the parentheses square. Number 2, y equals x squared minus 2. So we are motivated by those problems. Now, let's study some function curve shifting with the colors. If we are giving any function curve in the middle, y equals fx, then we can, on the xy axis, then it is with the vertical line test, we know this y equals fx gives a function, right? Gives a function. Then we can shifting to get the pink color curve, or shifting downward to get the green one, or shifting to the left, to the right to get the orange and blue colors. Now, how can we represent it? Now, let's check it. Black, so it's y equals fx. And then the pink color, we shift the graph of fx c unit upward, which gives the curve fx plus c. And then the green one, shift the graph fx c unit. Now let's check the vertical and horizontal shifting. Suppose c is a positive number. To obtain the graph of fx plus c, then shifting c unit upward. Then the whole function minus c, shift the graph a distance c unit downward, which gives that green color curve. Then fx minus c in the parentheses, shift the graph of y equals fx c unit to the right, which gives the blue color in the previous slide. Y equals x plus c in the parentheses, which shift the graph of y equals fx c unit to the left. Then it gives a orange color graph. Now, function curve stretching, besides the function shifting on the horizontal and vertical directions, we can also do the stretching and reflecting with the colors. In the middle, the black one is y equals fx. Then we can do the stretching and or make the y equals fx becomes more flat, which is shrink. So the pink one is stretch fx vertically by a factor of c, and then the green one shrink fx vertically by a factor of c. And those two, the orange and the blue one, are reflecting. The blue one is we reflect the curve y equals fx about the y-axis. That means they are mirror image about the y-axis. Mirror image about the y-axis. And the orange one, of course, it's a mirror image about the y-axis, which means we reflect about the x-axis. Now let's see how can we use the function to describe those different colors curve. Suppose c is greater than 1 to obtain the graph of c times fx, so which is a number greater than 1 multiplied by the function f. That means stretch the function vertically by a factor of c. Then if we multiply by a factor 1 over c, that means shrink fx vertically also by a factor of c. Now how about if we shift the constant c inside the parentheses, like y equals fcx. So this time, even though the c is greater than 1, but we will shrink the graph of fx horizontally by a factor of c. And then times 1 over c inside the parentheses. This is the number between this constant 1 over c is between 0 and 1. That is stretch the graph horizontally by a factor of c. Now let's see two reflecting case. If we put a minus in front of the function, then which means we reflect the function about the x-axis. You can imagine that like in the previous curve, our y equals fx is always positive. If you reflect about x-axis, then you always get the negative function value. If we reflect the curve about the y-axis, then our x becomes minus x. That is reflect about the y-axis. So those are some rules to state the vertical and horizontal stretching, shrinking, and two reflectings. Next, let's examples. Example to illustrate the stretching and shrinking. So we have already studied the trig function y equals cosine x, which is the pink one, okay, which is the pink one, from 0 to 2 pi. Then we stretch the cosine x by multiple number greater than 1. We multiply by 2. Then we get this blue one. Comparing the blue curve with the pink one, which means we stretch vertically by a factor of 2, then we get 2 times cosine x. If we times a constant between 0 and 1 in front of the function cosine, then that means shrink the function curve vertically by a factor of 2. Then we get the green color and it becomes a little flat comparing with the pink color, right? So that is the stretching and shrinking we did in the vertical direction. Now let's see in the horizontal direction. We have the cosine function in pink color, and then if we multiply by a number greater than 1 inside the function f, which gives cosine 2x, that means we shrink. Okay, we shrink the pink curve. So the period becomes pi instead of 2 pi, which is the green curve in the XOY axis. And if we multiply a number between 0 and 1, here 1 half. This is like f 1 half x inside the parentheses. So this one gives the green color, which means we stretch the cosine x and the period becomes 4 pi instead of 2 pi. So those two graphs based on the familiar trig function cosine x, we did the vertical stretching and shrinking, and we did the stretching and shrinking in vertical way as well as in horizontal way. Now let's see the first example. Given the graph of y equals root x, use transformations to graph the following functions: a, b, c, d, e. And we have already know y equals root x. You can take it as y squared equals x, which means you rotate the parabola y equals x squared by 90 degrees and you only take the positive part. Now this is a graph of y equals x squared. To get the x equals y squared, you just rotate the parabola by 90 degrees and only take the positive part of y, which looks like this one. This is the graph for y equals root x. Now let's see the first one. Root x minus 2, which is the function minus 2 shift 2 unit downward, like this one. Shift the graph 2 unit downward. B, y equals under the root x minus 2, which is f x minus 2 in the parentheses, which means shift 2 units to the right. C, y equals minus root x, which is minus fx. Then we reflect about x-axis. Okay, we get this new function curve. D, y equals 2 root x. That means 2 times fx. So we will do the vertical stretching. Get the pink color graph. E, y equals under the root minus x. That is f minus x. We will reflect the curve about the y-axis. Get this one. Now let's see the second example. Stretch the graph of the function fx equals x squared plus 6x plus 10. So first, if we only have x squared plus or minus a constant, we know we just do the vertical shifting. But here we have the sixth term involves the x again. So now let's completing the square. Then we rewrite the function. We can take it as x squared plus 2 times, we rewrite the 6x, 2 times 3x. So here we can take this term as a squared plus 2ab. Now, which implies my b is 3, then plus b squared, then plus 9. So here we separate 10 as 9 and 1. Now for this one, we can recall the formula. A plus b complete square is like this one. So we rewrite the function will be x plus 3 complete square plus y. Why we should rewrite the function in this way? Then we can start from the old function y equals x squared. Then we can come to x plus 3 complete square. Then we can recognize this is fx plus 3 in the parentheses, which means shifting 3 units to the left, right? Shifting the curve 3 units to the left. So here becomes the coordinate becomes minus 3, 0. Then we can come to x plus 3 squared plus 1. So which means we shift this middle function curve 1 unit plus 1 means 1 unit upward. So shift to upward. So this vertex becomes, the coordinate becomes minus 3, 1, which means the x value is minus 3, the y value is 1. Example 3. Then let's answer the question at the very beginning. How can we graph those two functions starting from y equals x squared? Then this one we shifting 2 units to the right. This one we shift 2 units downward, right? So it's easy. Now let's think about how can we draw the graph x squared minus 2 with the absolute value side.